are surrounded by thousands and thousands of stars. Are we alone in this vast cosmic landscape? Science is searching for an answer and has outlined two hypotheses. One, we are alone, and life is an anomalous fact that can only be explained by an unpredictable and eventful combination of circumstances. Two, life is implicit in the nature of the universe, and its appearance anywhere is unavoidable. The systematic search for extraterrestrial life has just begun. Its discovery would be the most important news in the history of mankind. Presently, from out there, only the echo of an intense silence reaches us. This gigantic diaphanous mass occupies a space that is 1,000 times greater than the solar system. It is one of the many interstellar clouds that the universe contains. Hundreds of organic molecules accumulate in its interior. Many of them are identical or similar to those that make up the living beings on Earth. As knowledge of the universe advances, it is confirmed that the ingredients of life do not exist only on Earth. To the contrary, as living beings, we are made from a raw material that is abundant in the universe.
We can think of the origin of life as perhaps in three different ways. In one extreme, life is a miracle. Life comes from God, a unique event. If so, science can't address the question because science can't address miracles. Miracles, by definition, defy natural law. But life may have been consistent with physics and chemistry, and yet a very rare, perhaps a unique event. Very improbable because of chance. And if so, again, science has trouble addressing the question because how can one go to a laboratory and study an improbable event? So only in the third case, if life is an inevitable consequence of chemistry and physics, if anywhere there's water and rock and air, life arises, then science can hope to answer the question.
When we ask ourselves about the mystery of life, we almost always look at the Earth for the answer. We have no other reference, although the Earth, with its inexhaustible variety of forms, plants and animals, is like a box of surprises and new questions, more than a direct answer. No one is sure where life begins and ends on Earth. Is it possible that something exists that is not just a copy, more or less advanced, than what we have on Earth? We already know, with much precision, what caused life to develop on our planet. Everything began with water, and with the release of certain chemical elements, like carbon and oxygen, which combined to form organic molecules. These molecules, thanks to the light of the sun, electric discharges from the atmosphere, and the energy from the interior of the Earth, became incipient living beings. Thus, starting with water, chemical elements, and a source of energy, the most elemental living organism known today appeared: bacteria. In 1953, the American chemists Stanley Miller and Harold Urey tried to reproduce the origin of life in a laboratory. They placed water vapor, methane, and ammonia in a test tube and ran a continuous electric current through it. Almost 1 week later, the water had acquired color and new compounds had appeared, including 2 amino acids, which are the basic building blocks of life. This combination, however, continued to be just as lifeless. Perhaps something similar to this experiment occurred on Earth. But if this is true, it was nothing more than another failed attempt that kept the planet, during its early stages, as a barren, lifeless place. Experiments aimed at reproducing the origin of life have helped science to define, with greater precision, the frontier between living material and lifeless material, between life and non-life.
There are a series of specific characteristics that make a living being different from a non-living being. For example, replication. A living being should replicate, generate progeny. It should produce offspring, whether they are molecular children or cellular children, meaning that replication should not be exact from father to child because we would lack diversity. In replication, there should be a series of mutations that introduce changes between the parental generation and the generation of the descendants. And these changes will make the descendants different from each other. Being different amongst themselves means they will react in different ways to stimuli, to selective pressure, and to environmental changes. Therefore, some will adapt better than others. Living beings, therefore, replicate and evolve, and they have a metabolism. This means that living beings are capable of carrying out a series of processes. Through the consumption of energy, they produce biomolecules. From a disorganized outside world, they produce organized molecules, which they use to grow and for their own metabolism. It's possible that these are the 3 fundamental characteristics of living beings: replication, mutation, and therefore evolution, and metabolism.
At the limit of these requirements, we find the viruses, which most scientists don't consider living beings. It's true that they reproduce and evolve, that they transform with several mutations, but they only do so when they infect a cell, which they use so that they can reproduce themselves. Thus, viruses only act as living beings when they act as parasites on a cell.
The question of this transition from non-life to life, that's in some sense a philosophical question, and yet many of us who work in the field have our prejudices. And mine is that the transition occurs when competition and natural selection begins. You can imagine inanimate nature, molecules, rocks, water. That's not alive, that doesn't compete. But at some point, a level of organization occurred in molecules, molecular systems that could replicate themselves. And when that happened, and because of the richness of organic molecules available, you had slight differences in these self-replicating molecules. Some were a little more efficient than others. And so life begins to compete for resources, for energy. And to me, the crucial stage in the origin of life is that very moment when competition led to selection. That's Darwinian evolution.
Every day, the great milestones in the path of the evolution of species are better understood. The first step of life is still unknown, however. In laboratories, biologists and chemists try to reproduce time and time again how this first gestation took place. To do so, the key is to manage to get certain chemical molecules to combine in a specific way, which is what provokes the miracle of life. The recipe of the great alchemist is a secret. Scientists have no other option but to continue investigating how the miracle of life occurred. And the only place where they know that this has happened is on the Earth. Just like the rest of the solar system, the Earth was formed over 4.5 billion years ago, when the remains of a supernova like this one crossed a vast cloud of cosmic dust. After this accidental birth, our planet was subject to bombardment by meteorites and comets during a large part of its history. During the first part of its existence, the Earth was an inhospitable place. Aside from external aggression, there was also great volcanic activity on its surface. This violent phase, however, favored the evaporation of water and the emission of gases like carbon dioxide and methane. The atmosphere was slowly created with these elements. If this had not occurred, the Earth would eventually have been burned by the sun's rays. During this infernal period, the basic broth, a kind of culture medium or breeding ground for life, was also formed. The water of the seas penetrated the cracks of the sea bottom and returned to the sea through the volcanoes. This water was enriched with minerals that it had taken from the heart of the Earth, which, when it came into contact with the atmosphere, provoked the Great Leap. Chemistry opened the way to biology and the appearance of the first bacteria. Present-day organisms could not survive in such a toxic environment, but the planet's path towards milder, stable conditions allowed the first signs of life to maintain themselves and evolve from their simple forms towards more complex beings. The impact of meteorites did not suddenly stop. In fact, many years later, the dinosaurs disappeared due to their effects. But fortunately, biodiversity was well developed at that time. And even though species disappeared in huge numbers, life was already deeply rooted. Hundreds of organisms were able to survive in the middle of the impressive destruction. Life on Earth has overcome a variety of climatic and environmental changes. But as radical as the changes may be, a living being that does not depend on water, oxygen, and solar energy, or one that can survive in such extreme temperatures, is not conceivable. In recent years, however, the discovery of organisms that live on the fringes of these laws are modifying our ideas about what a living being needs. These organisms are known as extremophiles, the lovers of very radical external conditions. These waters belong to the River Tinto in the southern Spanish province of Huelva. Its peculiar blood-red color, which gave it its name, is due to the metals that it bears. They come from the rocks that are dragged from its headwaters and from spillages from mines. Here, a community of living beings has been discovered that challenges the traditional point of view concerning the environmental conditions that allow for survival. These microscopic images have been recorded in these unhealthy waters, which show some organisms that assume basic vital functions without difficulties.
There are two extreme characteristics of the river: the low pH, in other words, the acidity of the system, which is around 2, and the high concentration of heavy metals. Heavy metals are toxic, especially those in the mining area of the River Tinto, essentially copper, which is used to prevent the growth of fungi in vineyards, and arsenic and cadmium, etc. The surprise was finding eukaryotic organisms, not the prokaryotes, the bacteria that eat minerals, but eukaryotes, algae, fungi, filament fungi, protozoans, amoebas, etc., which are present in a place where no one in their right mind would think that they could exist.
The mysterious life that is hidden in the River Tinto has disconcerted scientists, and not only because it is a unique class of extremophiles. It is extraordinary because in these conditions a certain degree of biological variety is developed, with more or less common algae, fungi, and amoebas. Their ability to adapt is such that we could say that they don't appear to be terrestrial. The first extremophiles were discovered a little over 30 years ago in Yellowstone Park in the United States. They were organisms that survived in temperatures over 100 degrees Celsius. They appeared in geological chimneys where water vapor emerged from the interior of the Earth. Scientists have also found living beings that are fond of extreme temperatures in the cold Antarctic rocks. In the ice, or in the lakes of water found below, they have found bacteria and algae living hundreds of meters below the surface. They are cold lovers, living beings that have the peculiarity of growing slowly, since the low temperatures slow down their metabolisms. At Movil Cave, in Romania, a group of several animals have lived isolated from the outside world for about 5.5 million years. There is no oxygen or light there, but 48 different species survive in this place. Its trophic chain takes advantage of the energy from the chemical elements that exist in the cave in order to produce nutritional substances for feeding. These strange mounds on the Australian coast are known as stromatolites. They are the fossil remains of bacteria that have been grouped in layers. The lower layers are formed by anaerobic bacteria, which are beings that, strange as it may seem, do not need oxygen to live. Even today, there is a class of organisms that exist in environments that lack oxygen, of which our intestine is one, among others. There are even more cases of life in anomalous conditions. In the Dead Sea, and in specific salt lagoons of Africa's Rift Valley, there are some salt-loving bacteria. To survive in a salty medium, these organisms have developed their own mechanisms to avoid dehydration.
The extremophiles are what allows us to open a series of scenarios, which means if there are microorganisms that can grow at high temperatures, the model of originating life in an underwater volcano at 100 or so degrees is not absurd, because today there are microorganisms that can do it. In a surface salt marsh with a high concentration due to evaporation, specific interactions are favorable, which can happen since there are microorganisms that exist in these conditions today.
If life emerged in such unfavorable environments, it is therefore a much stronger impulse than what our limited vision expected. The discovery of these living beings in unimaginable conditions has had repercussions among those searching for the presence of life in space. If life here was possible in conditions that were different from what we enjoy today, why couldn't the same thing happen on other planets? Geologists, biologists, chemists, and astrophysicists have come together in a new scientific field, astrobiology. They have established new expectations about what type of life to search for and where to look for it.
What we have successfully achieved is the collaboration of geologists and planetary astrophysicists and the people dedicated to the original evolutionary chemistry of our Earth. In this way, geologists give us a guideline, for example, as to how the planet has evolved into a physical body. At the same time, they join with planetary astrophysicists who explain how the Earth was formed and how this formation is the result of the evolution of the universe itself. On the other hand, the people who study evolutionary chemistry, complex molecules that evolve, enrich the knowledge of the geologists about what existed on the original Earth, the primitive Earth.
All these related sciences of astrobiology are drawn from a basic idea: the appearance of life as a natural phenomenon, as the inevitable consequence of a universe in continual change and evolution.
In the short to middle term, astrobiology is searching to contrast the idea that life is a cosmic imperative by applying the scientific method to it. The scientific method that is based on everything we know, from how a mobile phone works to how a bridge is built, or how to launch a spacecraft into outer space. This scientific method requires more than one example of a specific phenomenon. Life on Earth, as we know it, has extraordinary biodiversity, a biodiversity that is manifested in millions of different species on Earth. All of these forms of life, however, are based on certain unique principles, so that the phenomenon of life, as we know it on Earth, is the manifestation of a unique phenomenon. Therefore, the scientific method cannot be directly applied. As a result, we have to go to other places in order to contrast whether life exists or has existed.
In 1975, the direct search for life in the solar system began when NASA sent the Viking spacecrafts aloft with Mars as their destination. Today, the red planet is very cold, with average temperatures of minus 53 degrees Celsius, which has frozen the water that at some point covered its surface. It is dominated by a current geological relief of deep craters and dusty dunes, which gives it the appearance of a rocky desert. On the other hand, the absence of an ozone layer subjects Mars to relentless ultraviolet solar radiation. In this dead land, it would seem impossible to find life. The results of the tests carried out by the Viking mission confirmed this hypothesis, and the scientific interest in Mars was set aside. Studies of extremophiles on Earth, however, have put Mars back in the game. For scientists, the absence of signs of life in the two places where the Viking spacecrafts took samples is not final proof. They have to search other parts of the planet with milder environments and investigate the possibility that life manifested itself there in the past.
Well, I think, to me, the fact that we're seeing that life exists in these very extreme environments on Earth gives us optimism that we'll find life other places, because we know, for example, on Mars that there is liquid water at times. We know that there's ice. We know that there are very dry regions. There are probably very salty regions too. And so it seems to me that the fact that we find life existing on Earth in these extreme environments means that we don't know yet the limits. Every year the limits increase in terms of our discoveries. So why not broaden the limits a bit more to the environments of some of the planets?
I think Mars is the planet of greatest interest for astrobiological exploration. First, because it's nearby, and therefore is fairly easy to explore, or at least relatively easy to explore. And second, because although today Mars is a very forbidding planet, low temperatures, very little atmosphere, tectonically it appears to be almost dead at least. At the time that life emerged on Earth, Mars was a planet much more like our own, perhaps not identical, but much more. It had active volcanism, it had a thicker atmosphere, at least episodically it had liquid water. And so therefore, Mars is a good candidate to ask the question directly, did life appear more than once? And if it did appear on Mars, the way we will recognize it is, in general, the same way that we recognize evidence of ancient life on Earth, through microfossils, through the influence of microbial communities on sediments, and through chemical signatures that they impart to rocks.
(1984). A scientific expedition goes to the Antarctic to collect samples of meteorites. The solitude and the conditions of the frozen continent have kept them intact. Here, they discovered a rock that became a key piece in the investigation of Mars. It weighs almost 2 kilograms and is known as ALH. In 1996, at NASA, David Mckay and his team presented it to the public as a Martian meteorite with possible fossil evidence of certain living beings. Since then, the aerolite, alongside others that had been previously collected, have triggered a debate within the scientific community on whether or not we are standing before the definitive evidence that Mars also bore life.
We've been studying the ALH meteorite for a long time now. We're also looking at other Mars meteorites. There are now 18 different Mars meteorites, and we've looked in detail at about 4 of them. And we have found what we believe to be signs of life in all 4 meteorites that we have studied. First ALH, then Knoll, which fell in Egypt in 1911, and then Shergati, which fell in India, and then Lafayette, which was recovered in Indiana, USA. We think we see evidence for life. We have to prove it. We haven't proved it yet to the satisfaction of the scientific community, but we're working on that. How long will that take? Possibly a few more years. We hope that we can do that, either prove it or disprove it within, say, 3 or 4 more years. And that's what we're working on.
Through the study of meteorites and through new explorations, scientists hope to decipher the Martian enigmas in the period of just 1 decade. The European Space Agency is also participating in the race with the Mars Express, which will be launched in 2004. It is a satellite that will be placed in orbit around Mars and which has a landing module. Both devices will carry out in-depth studies of the planet, and with the images obtained, precise maps of the territory will be drawn up.
Since the American Viking missions in the 1970s, there has not been another mission with such a central astrobiological focus in its investigations as the Mars Express. And furthermore, this spacecraft has a landing vehicle, the Beagle 2, with a series of instruments to analyze the chemistry and organic substances of the planet, such as the rock minerals and the surface of Mars. It can also take images of the surface and measure the composition of the atmosphere around the landing area. It even has instruments able to reach a depth of between 1 and 1.5 meters in order to analyze the subsoil, which has not been affected by ultraviolet radiation, and where indications of life may be preserved better than on the surface.
Para analizar ese subsuelo que no ha sido afectado por la radiación ultravioleta, en el cual ha podido preservarse indicios de vida.
In addition to Mars, the scientific community is investigating other planets within the solar system. Mercury and Venus, due to their extremely hot climates, have been ruled out. Uranus, Neptune, and Pluto, due to their extremely cold climates, are not worthy of consideration either. Saturn and Jupiter are the only two left, two gassy giants where life seems impossible. These planets, however, have satellites orbiting around them that are arousing scientific interest. In the case of Jupiter, the moons Io and Europa, two satellites which, thanks to the energy of the planet they orbit, are much hotter than what was expected, given their great distance from the Sun. Io is the satellite with the most volcanoes in eruption in the entire solar system, which is a positive symptom. Due to the history of the Earth, it is known that volcanoes can play a fundamental role in the generation of life. In contrast, however, signs of water have not been detected yet, which for the moment reduces the hope of finding life. Europa seems to be a more gifted contender. Its frozen surface may shelter an enormous ocean below with organic molecules. If these were to exist, just as it happened on Earth, the discharge of some kind of energy may provoke the appearance of life. And in this aspect, there are also indications that the moon Europa has volcanoes, which is why some scientists hope that life exists or has existed there.
So Mars is our best candidate, but on a longer time scale, I think the exploration of Europa is going to be interesting. There's every reason to believe there is a long-standing water body, an ocean, if you will, on Europa, and that could have incubated life. It may actually have a higher probability than Mars of actually having still living organisms. So we might be able to look by biological techniques for life on Europa, whereas on Mars, I think largely it's going to be a paleontological exercise.
In the orbit around Saturn, there is a satellite called Titan, which, with a diameter less than half the size of the Earth, is very similar to our planet in other aspects. In 1980, the Voyager 1 spacecraft passed by Titan at a distance of 7,000 kilometers, which enabled it to carry out a detailed study. The images show a disturbing orange atmosphere with a touch of blue on the horizon, mainly made up of methane. According to the scientists who studied the data, the smell of the air of Titan should be like the inside of an oil refinery. Methane is the star gas of this satellite. It is suspected that it may exist in 3 states: solid, liquid, and gas. So perhaps there are giant oceans of methane with polar ice caps made up of this compound. It is also possible that there is an evaporation cycle and methane rain is produced. If this were true, it could be compared with the Earth and water, as if methane were able to fulfill the role that water plays on our planet. In this case, cells could exist that have methane in their interior, just like ours have water. If this hypothesis of methane beings were true, we would be dealing with organisms that live at very low temperatures with very slow biochemistry.
One of the key attributes for life on Earth is the presence of water. And I think it's fair to say that in most astrobiological exploration, people look for water first. And then if there is water on a planet or a moon, then perhaps there will be some sort of life. So the question becomes, is there another substance that might do the same job as water? And it has been suggested from time to time that methane could be a substitute for water as a substrate for life. If so, it's not easy to imagine what kind of life that would be. Certainly it would not be a life that would be easily recognizable in terms of our experience on Earth. Whether or not it's impossible, I don't know, but I would certainly think it would be much less probable than a life that is based on a watery environment. And so in that regard, when we think about a place like Titan, well, perhaps Titan could have given rise to life. It certainly has given rise to complex organic molecules. But in the absence of water, I think the probability that life would have emerged from that chemistry is much, much lower.
In 1998, the Cassini spacecraft was sent into space with Saturn as its destination. One of its missions is to study Titan, thanks to its atmospheric probe, which will descend down onto Titan's surface. This will take place in 2004. Starting then, perhaps the mystery of the methane satellite can be deciphered. The first explorations of the solar system have not provided proof of extraterrestrial life. But the absence of evidence, as paradoxical as it may seem, increases the belief that life is possible. The mechanisms of life are better understood today. Furthermore, it is also known that life can develop in much more open conditions than was originally believed. The question is, what kind of life are we dealing with? Instead of beings with antennae and extraordinary abilities, more realistic scientists assert that there is no intelligent life in our immediate cosmic environment. It's one thing to find unicellular organisms on a planet, but it's something very different to believe that these beings necessarily evolve into such complex forms as human beings. If Earth is the point of reference, the data is devastating. Of the millions of species that have prospered here, only one has been able to develop technological intelligence.
We can then say, well, what are the conditions that might favor intelligent life? And certainly one is environmental. You certainly need an environment that's capable of sustaining the biology of a large organism. And on our planet, that only became possible when oxygen rose to high concentrations in the atmosphere. And then second, one can ask what kind of lifestyles would facilitate the origin of intelligence. And there, certainly predation is important. Once you have to get your food by capturing prey, there is strong selective pressure for very, very sophisticated sensory apparatus and the neurological ability to integrate sensory apparatus. And there's also very strong selective forces favoring highly sophisticated muscular systems, and again, a highly sophisticated coordination of the neurological and muscular systems. Once those were in place, then I think the basic biological attributes that could lead to intelligence were there.
The lack of existing intelligent life in the proximities of the Earth does not mean that it cannot be found in other parts of the universe. Nothing is impossible within the magnitudes and dimensions of the cosmos. The universe has hundreds of thousands of galaxies, which at the same time have thousands of millions of stars, some of which are accompanied by planets. There are so many possibilities that we have to search far beyond the limits of the solar system. In 1996, the first extrasolar planets were detected, and since then their numbers have increased unceasingly, adding up to hundreds of them today. Most of them are big planets, normally located very close to their corresponding sun. The main difficulty is that they cannot be observed directly yet. Their existence is a deduction made from the behavior of the star.
The most successful technique so far for finding planets around other stars is the so-called radial velocity or spectroscopic technique. This technique is an indirect technique. You don't actually see the planet. What you see instead is the star moving around the center of mass of the planet-star system. That is, we all are familiar with planets moving around a star, but in addition, the star moves around on a much smaller orbit, the center of mass of the star-planet system. So we detect the planets by seeing the star move around, and we detect the stellar motion by looking at the line of sight changes in the velocity of the star using the Doppler technique, which you're familiar with from hearing a train whistle as a train is coming towards you or away from you. Same thing with the star. The star, as it's coming towards you, its light is shifted towards the blue. As it's moving away from us, it's shifted towards the red. So by watching very carefully how the spectral lines of the star change with time, one can infer that the star is moving back and forth on its orbit, and something must be causing that motion, and we now know that that is actually a planet.
NASA and the European Space Agency plan to place infrared telescopes in space in order to observe the extrasolar planets directly. If they have an atmosphere, that would be a good sign, since an atmosphere normally regulates extreme temperatures, which are found quite frequently on many planets. The telescopes will analyze these atmospheres in order to find evidence of the necessary chemical elements for life to be produced. Oxygen, which is present in our atmosphere, is one of the key signs of life, but it is not the only element that they are looking for.
There is also the signature of CO2, carbon dioxide, and water vapor. And these three compounds are all involved in the reaction that produce oxygen by biology, which is oxygenic photosynthesis. And if there are these three signatures, it could be a very, very good indicator for the presence of some photosynthetic activity. And another signature is the signature, spectroscopic signature of methane, because it seems that the primitive life forms on Earth could have produced huge amount of methane in the atmosphere, and this could be detected with very efficient telescopes. And
the possibility of an intelligent civilization in some corner of the universe has encouraged the sending of messages into outer space. These images place us in the year 1974, when a communication was broadcast from Arecibo, Puerto Rico, towards a dense ball of stars located 25,000 light-years away from us. If someone was able to decode the message, he or she, or it, would find a pictogram explaining the foundations of life on Earth. Meanwhile, some spacecraft sent into outer space, which are never going to return to Earth, have engraved plaques about who we are. The Voyager spaceships, more specifically, have all kinds of sounds and images, even those of animals, tribal songs, and a Beethoven string quartet. But almost 40,000 years will have passed before the Voyager approaches the first star. The SETI program is another initiative for establishing contact. They are doing more than just sending messages. They are now trying to receive them. That is, if there is an alien civilization that uses radio waves in its interstellar communications. 2 powerful radio telescopes are being used to detect radio signals from space, which are later analyzed in an enormous computer. Information is so abundant that the SETI program allows anyone who wants to use his or her computer to help with this task of distinguishing captured signals. When the computer is resting, a program is activated to analyze the data provided by the central computer. Almost 3 million people collaborate with the SETI program. Some curious signals have been detected, but after being thoroughly investigated, it has been proved that they were nothing more than telecommunication equipment interferences. To date, we have not received news from outer space. Western culture suffered an earthquake when Copernicus discovered that the Earth and man were not the center of the universe, but mere extras in a corner of the cosmos. The discovery of planets revolving around other stars now shows us that planets are a common occurrence. With this knowledge, someday it may be possible to solve the question of whether we, as the inhabitants of the Earth, do or don't represent the only life forms in the universe.
If we find living beings in other parts of the universe, it will be, without a doubt, the most important discovery in the history of mankind. We will therefore be able to show, and in a palpable way, that life is a consequence of the evolution of the universe. Furthermore, since we proudly believe that we are unique and the most powerful living beings, we will realize that we are nothing more than a coincidence, frozen in the evolution of the universe. This will add in an important way to our understanding of humility. As human beings, we should be humble, not only with respect to ourselves, but also with respect to other species that live on the planet. We should also give life the respect it deserves in every aspect.
If you imagine looking out above the Earth's atmosphere into the dark, starry night and imagining the immensity of the universe, it would be rather discomforting to think that we are the only sentient beings out there. I think it would make the universe feel like a much more pleasant place if we realize that somewhere out there on another rock orbiting another star like our own could be another sort of being, perhaps similar to us, perhaps not so similar, looking back in our direction and wondering if we existed.
Life beyond Earth is today a hypothesis more than a certainty. A new science, astrobiology, is knocking on the gates of the universe once again, with more improved technical equipment and greater knowledge. The cosmos will shine then with greater magnificence, and man will be amazed once again before this manifestation. After all, life, why not, just might emerge at any moment or in any place and in whatever form it chooses.